Welcome to the SC-25T Frogfoot. The Frogfoot, also called the Gratch, is a very capable ground attack aircraft that can destroy most anything on the battlefield. Before we start blowing things up though, let's first learn how to start up this bird and taxi to the runway. The first thing I'll ask you to do is turn on the electrical power by pressing right shift and L. With the electrical power now engaged, you can see that the heads-up display, or HUD, comes to life, as well as many instruments and cockpit lights. Before moving the aircraft, make sure that more than 3 minutes have elapsed in order to let the horizontal situation indicator gyro to align properly. Now that we have power, let's turn on the navigation lights by pressing right, control, and L. Next, let's close the canopy by pressing left, control, and C. Our next step is to start our two engines. Before you do so, make sure your throttle controller has a 0 power setting. Start the left engine by pressing right, Alt, and Home. With the left engine started, press right, control, and Home to start the right engine. Off the lower left corner of the TV display is the engine gauge, with needles marked 1 and 2 for the two engines. When an engine is being started, one of the two green lights below the gauge will light. Once the light turns off, it indicates that the engine is ready for operation. In the lower left corner of the dash is an aircraft symbol that indicates the status of your flaps, landing gear, and air brake. Lower your flaps to the takeoff position by pressing left shift and F. We're now ready to taxi, so slowly increase the throttles by moving the throttle control forward or pressing page up. To reduce throttle, use your throttle controller or press page down. To use the wheel brakes, press W. Start rolling forward and turn to the left of the taxiway ahead. Press Z to steer left and press X to steer right.
Ассистент, разрешаю руление на полосу 26.
Nice job. You're now heading in the right direction. Keep your taxi speed around 10 kilometers per hour as indicated in the top left corner of the HUD. As you taxi, use small, smooth rudder corrections to keep you aligned on the center of the taxiway. At the fork, hang a right to reach the runway. As we taxi, we can go to external view by pressing F2 and return to the cockpit by pressing F1. You can zoom in and out using the keypad star and / keys. Rotate the views using the keypad directional keys. You've now reached the runway threshold. Taxi onto the runway to the right and align yourself down the length of it. Once aligned down the runway, increase thrust of both engines to maximum and use gentle inputs on the rudder, X and Z, to keep it tracking down the center line. When your airspeed, as indicated in the top left corner of the HUD, indicates about 250 kilometers per hour, gently pull back on the controller and allow the aircraft to fly itself off the runway. Don't yank the controller back to force the aircraft into the air. As mentioned before, your airspeed in kilometers per hour is indicated in the top left corner of the HUD. The top right-hand corner of the HUD is your altitude in meters. Between the altitude and speed indications is your heading table. With positive climb established, raise the landing gear by pressing G. In the center of the HUD is the pitch and loading gear. On the right side of the HUD is the pitch level and vertical velocity indication. Go ahead and raise the climb by pressing left control. Welcome to this lesson on the basic flying and navigation of the Su-25T. This lesson will teach you how to get from point A to point Z and all points in between. I currently have the lesson in active pause. If you wish, you can turn on cockpit lighting by pressing L. Your airspeed is indicated at the top left corner of the HUD. The horizontal line below the airspeed indication with the caret below it indicates your acceleration or deacceleration. If the caret is on the left side of the line, you are deaccelerating. If it is in the center, your speed is not changing, and if it is on the right side of the line, you are accelerating. The smaller number above is your set airspeed for that leg of the route when you're in navigation mode. Press the spacebar to continue. Your altitude in meters is indicated in the top right corner of your HUD. An R to the right indicates it is radar altitude, or height above ground, and not barometric, height above sea level altitude. The smaller number above is your desired barometric altitude for that leg of the route. Press the spacebar to continue. You'll probably notice a circle in the center of the HUD. This provides you course steering to the next waypoint. By flying the aircraft to align the circle in the center of the bank and pitch indicator in the center of the HUD, you will reach your next destination on the course line. The course line is a direct line between two waypoints. Press the spacebar to continue. In the bottom center of your front dash is a horizontal situation indicator, or HSI, that looks like a compass. The yellow needle points directly to your next waypoint, and the top left field indicates the range of kilometers to that waypoint. The top right field indicates your course bearing to reach the next waypoint. The double white needles points to your course intercept. When you're on course to the next waypoint, with the yellow and white needles will align. Press the spacebar to continue. Ahead of you are a series of gates to fly through. Fly through the first gate directly ahead of you. You can push the control stick forward to push the nose down and dive, or pull back the stick to raise the nose and climb. These inputs control your elevator. Use the throttle, or page up and page down, to control your thrust. Try to keep your airspeed around 620 kilometers per hour. Press the spacebar when you're ready, and I will unpause the lesson. Note that when you pass through a gate, the next one's sequence will become larger if it's rather far away. If you get too fast, reduce the throttle and toggle your air brakes by pressing B. The next gate is above you and to the left. To change your heading, use your aircraft's ailerons to roll the aircraft to the left by moving your control stick to the left, and then gently pulling back on the stick until you are aligned with the next gate. The next two gates are below you and to the right. This time, roll the aircraft to the right and lower your nose to fly through the gates. to the next gauge directly ahead. As you go faster, your nose will want to rise, and as you go slower, the nose will want to fall. To keep your nose level, try using the trim. To trim the nose up, press right Control period. To trim the nose down, press right Control and semicolon.
Осталось 1500 килограмм. Предельный угол атаки. Предельная перегрузка. Предельный угол атаки. Предельная перегрузка.
In this lesson, we're going to learn how to navigate to an airfield and land on it. There are 3 navigation modes that we'll be using: en route, return to base, and landing. These submodes are selected automatically at appropriate points along the assigned flight path, but they can also be cycled manually. In this lesson, we'll use the automatic mode. I currently have the lesson paused as I explain some of the finer points. Press the spacebar to continue. this lesson is how to navigate to a waypoint using en route mode, switch to return mode automatically, and then switch to landing mode automatically. We're currently in en route mode, as indicated in the bottom left corner of the HUD. This mode allows us to fly from waypoint to waypoint in sequence automatically, as we did in the prior navigation lesson. However, in this lesson, we'll try manual selection. Our current waypoint is 0, our starting point, as indicated in the bottom right corner of the HUD with a range of 0. Press left control and tilde to manually select waypoint 1. Good. You will now see that waypoint 1 is selected with a range of 8.6 kilometers. Press left control and tilde again to select waypoint 2. You can see that waypoint 2 is 15.5 kilometers from us. As we learned in the prior lesson, you can see the direct heading of the waypoint is indicated by the yellow arrow on the HSI, and the twin white arrows indicate our path to fly the course line. Directly above the HSI is the Attitude Director Indicator, or ADI. This is a sphere with one hemisphere white and one hemisphere black. In the center of the ADI is a white aircraft symbol. This aircraft symbol stays stationary in pitch, but will rotate as you maneuver and roll. The ADI ball will move in pitch in relation to the aircraft symbol. When the aircraft symbol center is over black, your nose is below the horizon. If the aircraft symbol center is over white, your nose is pointing above the horizon. Press the space bar to continue. In the center of the ADI are two yellow lines that help assist you reach the waypoint via the course line. The course line is a direct line between two waypoints. The vertical line indicates your required azimuth steering to reach and maintain the course line. When the yellow vertical line is centered on the ADI, you are flying on or to the course line. If the vertical line is off to either side, put your stick in that direction until the vertical line centers on the ADI and adjust your roll to keep it centered. The yellow horizontal line indicates your elevation of course steering. When centered on the ADI, you are flying as you to set course altitude before the waypoint. The yellow line is in the lower left side of the ADI are your heading and elevation deviation scales. The more the lines are from center, the greater you are off the direct path to reach the waypoint. Let's practice this as we fly to waypoint 2. I'll unpause the lesson and you press the space bar. You'll first need to intercept the course line between waypoints 1 and 2. Note that the ADI steering bars and the HUD navigation circle provide us the same information. Fly the aircraft to center the ADI steering bars by adjusting the pitch and roll to keep the bars centered on the ADI. Or you can fly to keep the navigation circle on the HUD in the very center of the pitch and bank indicator. The choice is yours. Also remember that the assigned airspeed and altitude for the waypoint are indicated as smaller digits above your current airspeed and altitude. Fly to waypoint 2. In this lesson, we're going to learn how to navigate to an airfield and land on it. There are 3 navigation modes that we'll be using: en route, return to base, and landing. These submodes are selected automatically at the appropriate points along the assigned flight path, but they can also be cycled manually. In this lesson, we'll use the automatic method. I currently have the lesson paused as I explain some of the finer points. Press the spacebar to continue. What we'll learn in this lesson is how to navigate to a waypoint using en route mode, switch to return mode automatically, and then switch to landing mode automatically. We're currently in en route mode, as indicated in the bottom left corner of the HUD. This mode allows us to fly from waypoint to waypoint sequence automatically, as we did in the prior navigation lesson. However, in this lesson, we'll try manual selection. Our current waypoint is 0, our starting point, as indicated in the bottom right corner of the HUD, with a range of 0. Press left control and tilde to manually select waypoint 1. Good. You will now see that waypoint 1 is selected with a range of 8.6 kilometers. Press left control and tilde again to select waypoint 2. You can see that waypoint 2 is 15.5 kilometers from us. As we learned in the prior lesson, you can see the direct heading of the waypoint is indicated by the yellow arrow on the HSI, and the twin white arrows indicate our path to fly the course line. Directly above the HSI is the Attitude Director Indicator, or ADI. This is a sphere with one hemisphere white and one hemisphere black. In the center of the ADI is a white aircraft symbol. This aircraft symbol stays stationary in pitch, but will rotate as you maneuver and roll. The ADI bar will move in pitch in relation to the aircraft symbol. When the aircraft symbol center is over black, your nose is below the horizon. If the aircraft symbol center is over white, your nose is pointing above the horizon. Press the spacebar to continue. In the center of the ADI are 2 yellow lines that help assist you reach the waypoint via the course line. The course line is a direct line between the 2 waypoints. The vertical line indicates your required azimuth steering to reach and maintain the course line. When the yellow vertical line is centered on the ADI, you are flying on or to the course line. If the vertical line is off to either side, put your stick in that direction until the vertical line centers on the ADI and adjust your roll to keep it centered. The yellow horizontal line indicates your elevation course steering. When centered on the ADI, you are flying at or to the set course altitude for that waypoint. If the yellow line is in the lower half of the ADI, push the stick forward until the yellow horizontal line centers on the ADI and adjust pitch to keep it centered. Conversely, if the yellow horizontal line is above the center line of the ADI, pull back on the stick until the line centers. Along the top and left side of the ADI are your heading and elevation deviation scales. The more the lines are from center, the greater you are off the direct path to reach the waypoint. Let's practice this as we fly to waypoint 2. I will unpause the lesson when you press the spacebar. You will first need to intercept the course line between waypoints 1 and 2. Note that the ADI steering bars and the HUD navigation circle provide us the same information. Fly the aircraft to center the ADI steering bars by adjusting the pitch and roll to keep the bars centered on the ADI. Or you can fly to keep the navigation circle on the HUD in the very center of the pitch and bank indicator. The choice is yours. Also remember that the assigned airspeed and altitude for the waypoint are indicated as smaller digits above your current airspeed and altitude. Fly to waypoint 2.
Опусти шасси.
In the past two lessons, we learned the basics of navigation and landing under ideal conditions. In this lesson, we're going to put what you learned to the test by finding an airfield and landing on it at night during a thunderstorm. Sounds fun, huh? Let's turn on the cockpit light by pressing L. We're currently in route mode, but we have no airfield at the final route destination. So let's select return mode by pressing 1. As I mentioned in the last lesson, the airfield identification number is displayed in the lower right corner of the HUD. 21 is the ID code for Beslan Airfield, the smallest runway I could find in the game just for you. If you want to get return steering to a different airfield, you can press left control and tilde until you select the airfield you want. A complete list of airfield ID numbers is located in the back of the SU-25T flight manual. For now, let's keep it on 21. Press the spacebar to continue. Using what we learned about course steering through the HUD and ADI, fly the assigned return course that will lead you to the ILS intercept for Beslan Airfield. As you start to descend, you'll probably pick up a lot of speed. Don't forget that you can deploy the air brakes by pressing B. As we get closer to the airfield, I should also mention that not all have Russian ILS, as we had in the last lesson. Airfields that do include Mozdok, Krimsk, Maikop, Krasnodar Center. The unit does not have this. We will not have the high resolution. However, if you look under the HSI, you'll notice a dashed cross in the center with solid vertical and horizontal lines. The dashed lines are fixed and represent the optimal right. Press the space bar. In this lesson, we're going to learn how to deliver unguided bombs in the Continuously Computed Impact Point Mode, or CCIP. Unguided bombs of the SU-25T include the Fab 100, Fab 250, Fab 500, RBK cluster bombs, and Beta penetration bombs. In this case, I have two racks of Fab 100s and a couple of larger Fab 100s. Each of the Fab 100s has a high explosive load, and a number of minimums to increase the bomb's weight in kilograms. I currently have less than 100 bombs. The first thing I need to do is select air to ground by pressing 7. Do this now. Note that the HUD has changed to remove most of the navigation information and replaced with bomb symbology. We'll talk more about this soon. You can switch your weapons by pressing D. Try this now. When you cycle a weapon, take a look at the weapon status panel in the bottom center of the front dash. It's the black panel with the shape of a wing along the top. There are two rows of lights below. The top row of yellow lights indicates the weapon stations that have weapons attached to them. And the lower row of green lights indicates weapon stations that are loaded with the currently selected weapon type. In the top right corner of the panel, a B symbol is displayed. This indicates that the selected weapon type is a bomb. You can also see the symbol in the lower right corner of the HUD. By pressing left control and spacebar, you can set the ripple quantity, meaning how many bombs are released when you press and hold the weapon release button or trigger. Try this now. As you cycle ripple quantity, take a look at the weapon control panel in the lower left portion of the front dash. On the panel are two knobs. The right knob has positions for X1, X2, X4, and DCE. The position of the knob determines how many bombs will be released, as singles, in pairs, four at a time, or all at once. You can set the release interval by pressing V. This determines the time between each bomb release. Longer intervals result in greater spacing between bomb impacts. You can view the setting by looking at the position of the left knob on the weapon control panel. The knob has positions for 0.1, 0.2, 0.3, and 0.4 seconds. The last position indicates salvo mode, in which all weapons are released simultaneously. Give this a try. Press B to cycle the releasing mode. Those are the basics of configuring your settings for bomb release. Now let's learn how to put those bombs on target in CCIP mode. Using what you learned in the navigation lessons, fly through all the gates ahead. Press the spacebar to unpause the lesson. If you are not already, press 7 to enter air-to-ground mode.
Предельная перегрузка. Предельный угол атаки. Предельная перегрузка.
Welcome to the Cockpit Overview lesson. Today, we will take a detailed look at the Mustang cockpit. You can use mouse look mode to move your view around the cockpit. To turn mouse look mode on and off, press left Alt plus C. Throughout this lesson, pressing the spacebar key will initiate the next consecutive step once instructions for the current one are complete. Press the spacebar key when you are ready to begin. The cockpit is configured in a standard layout, with the instrument panel positioned on the front dash, a center-mounted control stick, a throttle quadrant on the left side, and various aircraft system controls on the left and right panels. With the exception of the flaps control handle, which is located in the bottom left corner of the cockpit, most of the indicators and controls are well organized and easy to read and reach. Moving on to the instrument panel, the upper left corner houses the remote indicating compass. The compass unit is installed inside the left wing and transmits magnetic readings electrically to the cockpit indicator. Using a remote compass avoids the magnetic effects caused by armor plating around the cockpit, experienced by a standard magnetic compass. The remote indicating compass includes a heading needle, which shows the current heading, and a desired heading needle, which can be turned using the indicator knob to set a desired course reference on the indicator. To turn the knob, you can simply roll the mouse wheel over it. To the right of the remote indicating compass is a standard clock. The winding knob can be used to set the time. Doing so requires pulling the knob out with the left mouse button, then rolling the mouse wheel over the knob to rotate it. The suction gauge indicates the amount of pressure in inches of mercury being generated by the engine vacuum pump. Vacuum pressure is used by a number of vital instruments, including the flight indicator, bank and turn indicator, and the directional gyro. A suction reading above or below normal means the readings of these indicators are unreliable. Next is the manifold pressure indicator. This is one of the primary instruments used in flight, and together with the tachometer or engine RPM indicator is your main reference of engine power. The manifold pressure indicator shows gas pressure inside the engine induction system prior to entering the cylinders. Like the suction gauge, the indication is in inches of mercury. Manifold pressure is set using the throttle handle, while engine RPM is set using the propeller control lever, also on the throttle quadrant. On the left side of the middle row of the instrument panel is the airspeed indicator, which shows an indicated airspeed in miles per hour, mph. The red line on the indicator marks the maximum permissible airspeed of 505 miles per hour. It's important to remember that maximum permissible indicated airspeed is reduced as altitude increases. For example, it is 400 mph at 20,000 feet and 300 mph at 30,000 feet. In the left center of the instrument panel is the directional gyro, which shows current heading. The instrument can be caged and the heading adjusted manually by pushing in and rotating the indicator knob. In the center right of the instrument panel is the flight indicator, which shows the aircraft's roll and pitch attitude relative to the horizon. The indicator is limited to 60 degrees in pitch and 100 degrees in roll. The instrument can be caged or uncaged using the caging knob in the lower right corner of the indicator. The horizon level can be adjusted vertically using the pitch adjust knob. To the right of the flight indicator are two temperature gauges, the coolant temperature gauge above and the carburetor air temperature below. It's important to monitor these instruments in flight, as temperatures rising above normal may lead to serious engine problems, such as detonation and pre-ignition. On the right side of the middle row of the instrument panel is the tachometer. This instrument indicates engine speed in revolutions per minute, RPM. The pilot controls engine speed using the propeller control lever on the throttle quadrant. A propeller governor system automatically adjusts propeller pitch angles to maintain the RPM set by the pilot. Typical RPM settings in flight will be between 1,800 and 3,000 RPM. Moving to the bottom row of the instrument panel, the left corner houses the altimeter. The altimeter shows barometric or pressure altitude using a 3-needle system. The shortest needle shows altitude in tens of thousands of feet, the middle needle in thousands of feet, and the longest needle in hundreds of feet. The indicator knob is used to adjust the sea level reference pressure in inches of mercury to ensure an accurate altitude reading over a desired location where the sea level air pressure is known. Next is the bank and turn indicator, primarily used to maintain coordinated flight and minimize side slip. The vertical needle of the instrument indicates turn rate, and the slip ball indicates side slip or side skid. In flight, the pilot maintains the ball's center by using stick and rudder controls or aileron and rudder trim. Flight trim is very sensitive to changes in engine power and airspeed, so constant attention must be paid to the bank and turn indicator in order to fly as efficiently as possible. To the right is the rate of climb indicator, which shows the climb rate in thousands of feet per minute. Further to the right is the accelerometer, or G-meter. This indicator shows the G-load factor experienced by the aircraft, as well as two additional needles that show the maximum and minimum G-loads attained since the instrument was last reset. The instrument includes a reset button used to reset the needles to 0. Finally, on the very right is the engine gauge. This instrument includes 3 indicators: the oil temperature gauge, oil pressure gauge, and the fuel pressure gauge. Moving below the instrument panel, the engine control panel includes a number of important engine controls. These include supercharger blower switch, sets the supercharger to low, high, or automatic blower modes. Normally this should be set to auto. The jewel light indicator lights up when the supercharger kicks into high blower mode. Fuel booster switch, turns the fuel booster pumps on and off. Oil dilute switch, used to dilute the oil with gasoline, which may be necessary when starting in cold temperatures. Starter switch, used to turn the engine prior to ignition during startup. Primer switch, used to feed fuel to the engine through the fuel primer system during startup. To the right are the 2 landing gear warning lights. These indicate safe or unsafe states of the landing gear. For example, the unsafe red light will be on if the gear doors are open but the landing gear is unlocked. Adjacent to the landing gear warning lights is the parking brake handle. Setting the parking brake requires the following steps. Pull out and hold the parking brake handle. Fully depress and release the brakes. Release the parking brake handle. Releasing the parking brake only requires a press of the brake pedals. On the right side below the instrument panel are the oxygen indicators, the oxygen flow indicator, and the oxygen pressure gauge. The oxygen flow indicator features a blinker that opens and closes as the pilot inhales and exhales on-demand oxygen. The oxygen pressure gauge shows the amount of oxygen remaining in the O2 tanks in pounds per square inch, psi. A normal reading is 400 psi. Just below the instrument panel is the front switch panel, which includes a variety of important controls. Ignition selector switch selects the left, right, or both magnetos to operate the engine ignition system. Cockpit light switch turns on and adjusts the cockpit floodlights. Horn silence button silences the AN/APS-13 rear warning radar alarm. Below the front switch panel is the fuel control panel. This includes the fuel shutoff valve, used to open and close the fuel flow, and the fuel selector valve, used to select the fuel tank used to feed the engine. Correct fuel tank selection is important in flight to maintain a balanced aircraft. To the right of the fuel control panel are the hydraulic pressure gauge and the landing gear fairing doors emergency release handle. The landing gear fairing doors emergency release handle can be used to release the hydraulic pressure and mechanical locks holding the gear doors closed. This will open the fairing doors and allow the landing gear to fall down under its own weight. Slight rolling of the aircraft from side to side can be used to ensure the gear locks in place prior to landing. Normal pressure for the hydraulic system is 800 to 1100 psi. The surface control lock is used to lock the control stick in place when the aircraft is parked. Left-clicking over the pin locks the stick in the forward position, which leaves the tail wheel unlocked and allows the aircraft to be towed and turned easily. Right-clicking on the pin locks the stick in the neutral position, which leaves the tail wheel limited to 6 degrees of turn. Moving to the left side of the cockpit, the throttle quadrant dominates the forward section. The throttle quadrant includes the throttle handle, the propeller control lever, and the mixture control lever. In addition, 2 friction locks are mounted on the assembly and can be used to stop the movement of the throttle handle or the mixture and propeller control levers. The throttle handle features a microphone switch button used to activate transmission over the VHF radio. Moving back from the throttle quadrant, the radiator air control panel includes switches to operate the coolant and oil radiator flap doors. These are usually kept in automatic, but can be opened and closed manually when necessary. This panel also includes the landing light switch and the left-hand fluorescent light rheostat switch, which controls instrument backlighting on the left side of the cockpit. 3 trim wheels are used to set the aileron, rudder, and elevator trim. Take off with 5 to 6 degrees of right rudder trim to help compensate for engine torque. Trim settings in flight may vary depending on flight conditions. The 2 handles toward the left rear of the cockpit control airflow to the engine induction system. The ram air control handle controls whether air is ingested through the main intake under the nose or filtered intakes on either side of the nose. Filtered air is used when icing of the intake develops. The hot air control handle opens a vent door in the engine compartment to allow warm air to enter the carburetor. This can be done below 12,000 feet when icing of the carburetor is a danger. Probably the most awkward control in the cockpit is the flaps control handle in the bottom left corner. The flaps can be set from 0 to 47 marked 50 degrees in 10-degree increments. The landing gear control handle is also on the left side. The handle is pulled in and moved up or down to raise and lower the landing gear as desired. The gear should only be moved when it's locked in either the up or down position. Now moving on to the right side of the cockpit, we have 2 canopy controls. The canopy is rolled open and closed by turning the canopy hand crank. The red handle is the emergency canopy release. When pulled, this will unlock the canopy and it will fly off into the slipstream. The oxygen regulator is used to control oxygen flow to the pilot's mask. The oxygen diluter lever, marked with yellow stripes, is used to set normal diluted oxygen or 100% oxygen. The red emergency valve is a separate backup oxygen line and can be used to bypass the regulator. The recognition light's keying switch is used to flash the recognition lights installed on the underside of the right wingtip when they are set to key mode on the electrical panel. The lights turn on for as long as the keying switch is held down and off when it is released. The electrical control panel includes switches for battery and generator power, pitot tube, and external lighting. In addition, the right-hand fluorescent light rheostat switch controls the backlighting for instruments on the right side of the cockpit. The electrical control panel also includes an important indicator, the ammeter. This shows current output of the generator in amperes. Maximum permissible output is 100 amperes. The ammeter does not show battery current. Finally, the electrical control panel also includes a circuit breaker bump plate. This can be pressed in to reset all the circuit breakers in case one or more of them gets overloaded and pops out. Further back from the electrical control panel is the AN/APS-13 Rear Warning Radar, or RWR. This device sounds an alarm when an object is detected behind the aircraft to warn the pilot of a possible threat approaching from the rear. Next is the SCR-522 VHF radio, used for communication with flight members and air traffic controllers. The radio features 5 channels, the frequencies for which are preset and cannot be changed in flight. You should consult your mission briefing prior to starting a flight to ensure your radio is set up to contact ATC towers in your vicinity. The remaining radio systems, including the homing adapter, IFF transponder, and Detroller range receiver, are not functional in this aircraft. Let's now take a look at the fuel gauges. You may need to twist your head around the cockpit a little to see them. You can press left Alt plus C to enable mouse view mode, and then hold down the mouse wheel while moving the mouse to move your head around the cockpit. The gauges for the left and right main tanks are located on the floor to either side of the seat. Finally, the area under the seat also houses cockpit environmental controls, including windshield defrosting and cockpit heating and cooling. This concludes the cockpit overview lesson. Next time, we'll learn how to start her up. Welcome to the startup lesson. Press the spacebar key to begin. The engine start sequence is not very complicated. We will move around the cockpit clockwise, starting on the left side to configure the aircraft for engine start. Let's begin with the flaps control handle, positioned to the rear bottom left side of the cockpit. For a normal takeoff, flaps are not usually lowered. However, 15 to 20 degrees of flaps can be used when a minimum run takeoff is required. Set the flaps control handle all the way up to the up position. To do this, you can either click and drag the handle with the mouse or press left shift plus F command repeatedly until it is all the way up. Note, the flaps won't actually come up until the engine is running and there is sufficient pressure in the hydraulic system to raise them. Now set the carburetor induction system for normal operation by moving the cold air control handle all the way forward to the ram air position and the hot air control handle all the way forward to the normal position. Next, set the coolant and oil radiator air control switches to the auto position for automatic operation of the coolant and oil radiator flap doors. To do so, left-click on the auto switch positions. Don't forget to close the switch covers after. Adjust the trim tabs to prepare for takeoff. Set rudder trim to 5 degrees right. Elevator trim can be left neutral. Aileron trim remains neutral. On the throttle quadrant, ensure the propeller RPM lever marked P is set all the way forward to increase and the fuel mixture lever marked M is set to idle cutoff. Set the throttle handle about 1 inch forward from the fullback position to slightly open the throttle butterfly valve and allow air to flow to the engine. If you don't have a throttle controller, the plus and minus keys on the keyboard numpad can be used to move the throttle handle. Moving to the engine control panel on the front dash, turn on the fuel booster pump by setting the fuel booster switch to the up position by clicking over the switch. Select the left and right magnetos to provide power to the engine ignition system by setting the ignition switch to both. On the fuel control panel, ensure that the left wing tank is selected for fuel consumption by checking that the fuel selector valve is set to the main tank LH position. Open the fuel shutoff valve by clicking on it to set it to the on position. Let's set the parking brake to make sure we remain stationary when the engine begins to pull. You may want to open the controls indicator by pressing right control plus enter to monitor the positions of your flight controls, including the brakes. Setting the parking brake takes a few steps. First, pull out and hold the parking brake handle by clicking and holding it. Next, while continuing to hold the parking brake handle, fully press the brake pedals by holding down the W key. Continuing to hold the parking brake handle, release the wheel brakes by releasing the W key. Now release the parking brake handle to set the parking brake. If done correctly, the parking brake handle should remain in the pulled out position. We'll now move on to the electrical control panel on the right side of the cockpit. Set the battery switch to the up position to provide electrical power. Also, set the generator switch to the up position to prepare the generator to take over once the engine is running over 1500 to 1700 RPM. Click and hold the primer switch on the engine control panel for about 1 second to feed some fuel to the engine. When starting in cold temperatures, up to 4 seconds of prime may be necessary. We are now ready to attempt an engine start. To do so, first press and hold the starter switch to operate the starter and begin turning the engine. As the engine begins to catch, move the fuel mixture control lever on the throttle quadrant to the run position by right-clicking on it once. If you aren't able to start the engine successfully, return the fuel mixture lever to idle cutoff by left-clicking and repeat the process starting with priming the engine. Note, the engine starter can be easily overheated. The starter should not be used for more than 4 20-second attempts to start, with 15-second intervals, followed by a 5-minute cooling off period. Welcome to the startup lesson. Press the spacebar key to begin. The engine start sequence is not very complicated. We will move around the cockpit clockwise, starting on the left side to configure the aircraft for engine start. Let's begin with the flaps control handle, positioned to the rear bottom left side of the cockpit. For a normal takeoff, flaps are not usually lowered. However, 15 to 20 degrees of flaps can be used when a minimum run takeoff is required. Set the flaps control handle all the way up to the up position. To do this, you can either click and drag the handle with the mouse or press left shift plus F command repeatedly until it is all the way up. Note, the flaps won't actually come up until the engine is running and there is sufficient pressure in the hydraulic system to raise them. Now set the carburetor induction system for normal operation by moving the cold air control handle all the way forward to the ram air position and the hot air control handle all the way forward to the normal position. Next, set the coolant and oil radiator air control switches to the auto position for automatic operation of the coolant and oil radiator flap doors. To do so, left click on the auto switch positions. Don't forget to close the switch covers after. Adjust the trim tabs to prepare for takeoff. Set rudder trim to 5 degrees right. Elevator trim can be left neutral. Aileron trim remains neutral. On the throttle quadrant, ensure the propeller RPM lever marked P is set all the way forward to increase and the fuel mixture lever marked M is set to idle cutoff. Set the throttle handle about 1 inch forward from the full back position to slightly open the throttle butterfly valve and allow air to flow to the engine. If you don't have a throttle controller, the plus and minus keys on the keyboard numpad can be used to move the throttle handle. Moving to the engine control panel on the front dash, turn on the fuel booster pump by setting the fuel booster switch to the up position by clicking over the switch. Select the left and right magnetos to provide power to the engine ignition system by setting the ignition switch to both. On the fuel control panel, ensure that the left wing tank is selected for fuel consumption by checking that the fuel selector valve is set to the main tank LH position. Open the fuel shutoff valve by clicking on it to set it to the on position. Let's set the parking brake to make sure we remain stationary when the engine begins to pull. You may want to open the controls indicator by pressing right control plus enter to monitor the positions of your flight controls, including the brakes. Setting the parking brake takes a few steps. First, pull out and hold the parking brake handle by clicking and holding it. Next, while continuing to hold the parking brake handle, fully press the brake pedals by holding down the W key. Continuing to hold the parking brake handle, release the wheel brakes by releasing the W key. Now release the parking brake handle to set the parking brake. If done correctly, the parking brake handle should remain in the pulled out position. We'll now move on to the electrical control panel on the right side of the cockpit. Set the battery switch to the up position to provide electrical power. Also, set the generator switch to the up position to prepare the generator to take over once the engine is running over 1500 to 1700 RPM. Click and hold the primer switch on the engine control panel for about 1 second to feed some fuel to the engine. When starting in cold temperatures, up to 4 seconds of prime may be necessary. We are now ready to attempt an engine start. To do so, first press and hold the starter switch to operate the starter and begin turning the engine. As the engine begins to catch, move the fuel mixture control lever on the throttle quadrant to the run position by right-clicking on it once. If you aren't able to start the engine successfully, return the fuel mixture lever to idle cutoff by left-clicking and repeat the process starting with priming the engine. Note, the engine starter can be easily overheated. The starter should not be used for more than 4 20-second attempts to start, with 15-second intervals, followed by a 5-minute cooling off period. Good start. Now we need to make sure the engine is running smoothly without any indications of a problem. Use the RPM gauge and adjust the throttle to run the engine at about 1200 to 1300 RPM. Monitor the engine gauge to check the oil pressure to reach at least 50 psi and the oil temperature to reach at least 40 degrees Celsius. Check the suction gauge to make sure it is showing a normal suction reading of 3.75 to 4.25 inches. Press the spacebar key to proceed. Check the oxygen pressure gauge to make sure it is reading a normal pressure of 400 psi. Press the space bar to proceed. Continue to idle the engine at 1,000 to 1,200 RPM until ready to taxi or perform a pre-flight check. Remember to release the parking brake before taxiing. To do so, fully depress and release the wheel brakes carefully. This concludes the engine start lesson. Well done.
Placed on approach to Mazda Airfield Terrain. Get her down one place. Press escape and then select briefly to view a list of useful keypoints.
Предельный угол атаки. Предельная перегрузка. Предельный угол атаки. Предельная перегрузка.